Hello, everyone. Welcome to today's webinar, part of the inaugural Asia Pacific DNS Forum, which will be held in March of 2022. My name is Jarong. I'm the Managing Director of the ICANN Asia Pacific office, and I'm going to be your moderator for today. The upcoming inaugural APAC DNS Forum is hosted by MyNIC and ICANN, and is envisioned to gather our regional DNS industry experts and the wider community to discuss the latest developments, opportunities, and challenges in the domain name marketplace. It is also envisioned to be a platform for our regional DNS community to network, exchange ideas, and explore collaboration opportunities. In a way, this will also be a lead-up event as the international community is slated together in Kuala Lumpur for the 75th ICANN public meeting, which is planned for September 2022. So this first webinar is the first of 6 pre-event webinars, which I aim to do a couple of things. The first would be to level set and introduce the basics so everyone can join the conversation during the actual event, and also to see key topics which we can discuss more in depth during the actual forum. So at today's kickoff webinar, we are going to start with the most basic of all, understanding the DNS. And you can join us either through Zoom or on YouTube as well. So I'm going to approach today's topic with a more conversational format, and I hope you stay with me as we discuss not just how the DNS works, who's behind it, how important it is, and also its impact on our ability to come online. I think this conversation remains very relevant and important, especially during the entire COVID-19 pandemic, when most of us have to do work virtually. Now, without further ado, let's get started. So allow me to introduce our speakers. So we have 3 guest speakers today. The first is Champika Wijayatunga, Technical Engagement Manager from ICANN. And the second is Mastura, who is the lead of IT services for MyNIC. And our third guest is Zhang Mingkai, also known as Mike. He is the DNS Senior Engineer for Alibaba Cloud. Now, for our 3 speakers, introduce them a little bit more. So Champika is very well known in the region. He's trained a large number of technical personnel and contributed to enhancing the region's internet infrastructure, including the deployment of DNSSEC in several organizations. And Mastura, one of her achievements, being the lead of IT services for MyNIC, is the adoption of DNSSEC for the Malaysia government. And right now, 50% of gov.my has enabled DNSSEC, which is also a good achievement. And Mike, he is responsible for the stability of Alibaba's global large-scale DNS system. Now, let's start talking about the DNS. So let's talk about the basics so everyone watching can join the conversation during the next subsequent months leading up to the actual event for the DNS forum. Let's go to Champika first. Champika, welcome.
Yeah, welcome, Jarong, and welcome everyone. First of all, thank you very much for giving this opportunity and inviting me for this panel.
Thanks for joining, Champika. Now, as mentioned, Champika trained hundreds of technical personnel and is very well known in the technical community. In fact, within our APAC region, a lot of people know Champika even before they know ICANN. And even personally, I'm indebted to Champika because much of what I know about the DNS, I've learned from him. So we are in for a treat to learn a bit more about the DNS, even if you're not familiar. So Champika, can you share with us first, what is the DNS in the first place?
Yeah, actually, see, in layman terms, if you take DNS, you can say that it is the entry point to the internet. But I would like to actually have a little bit of discussion so that maybe the things that we are going to talk is more clearer. So let me just try to share a few slides so that it's more clearer. So I hope that you can see my screen.
Yes, it's up. Go ahead, Champika.
All right. Yes. Now, the question that you asked was, what is DNS? So I did say that in very layman terms, it is the entry point to the internet. But the DNS is actually, or simply we call the domain name system, so which is designed to make the internet accessible to human beings. Now, I would try to focus here a bit more on to the word human beings, because that's all of us, because nowadays, we use internet very often on a daily basis. We use several applications. We do browsing, we send emails and use mobile apps and things like that. So we interact with lots of applications. And so that is why it is very important for us to think of DNS as well. Now, so from this context, it's quite important for us to understand the protocols behind internet. Now, you may have heard about TCP/IP, because TCP/IP is the underlying protocol behind, the internet, and it has been there, for like 40 years or so. And so we need to understand a bit about, how TCP/IP is structured and how the data packets flow from one place to another place. So this would give some better context about DNS. Now, if you see here in TCP/IP, so this is the protocol that we are talking about. So when I say protocol, it's a set of rules, and there are layers. So it's more of a layered approach that we are talking about here. So you can see there are 4 layers here: application, transport, network, and physical. Now, application is the layer that the users, the humans that we all interact with. I told you about the humans earlier, so we all interact with the application layer. For example, if you browse, you use a application like a browser, or if you're going to send emails or use mobile apps, you would use an application. So that's the layer that we interact with. And then we provide this input as a bit stream, and then this bit stream has to be sort of packaged in a way that we could transport this. So that's all happening in the transport layer. And then we have the networking layer, which is quite important, because this is where we give directions. So the data packets has to flow from one place to another place. So which means we need to give directions. So this is where the addressing comes in, and the routing function comes in. So when we say addressing, the IP addresses come into the picture. And so these IP addresses, we have 2 different versions, IPv4 and IPv6, which is not very easy for humans to remember. And this is why actually DNS is very important for us. And of course, in the last layer, the physical layer, we have the physical infrastructure where we can get these data packets from one place to another place. So I was telling about the mapping here, because we have these IP addresses which we can't really remember, and that is why we need some kind of a naming structure that we can map so that the humans can easily remember. So we have to think about some sort of a naming structure. Now, this naming structure is quite organized. And so in this graphic, what you see here now, so simply what we have is a mapping. So we try to map these names that we can remember into numbers. Numbers are those addresses that I was talking about. And you can see that these names are properly structured. There has to be a proper structure. And so on the graphic, you can see that there is a hierarchical naming structure. This is in fact actually organized as a database, or you can say that it is a distributed database. And top of the hierarchy is what we call the root. And then we have things called top level domains. Then we have things called second level domains and so on. Now, if you think of this particular host, so we have a host here called www, a web server. Now, this web server has got a hierarchical sort of, delegation. And so the address or the domain name, the host name that it has got is something called www.example.com, if you see the hierarchy. But actual fact, behind this web server, what you have is an IP address. So this could have an IPv4 address, or this could have an IPv6 address. But for humans, it's not going to be very easy to remember these addresses. And especially, if you think of IPv6 address, that's going to be very, very hard. I mean, maybe for some technical people who are managing these servers or this infrastructure, they might be able to probably remember, some of these IP addresses that they operate. But for general public, for the normal users, it is not going to be very easy to remember these addresses. So that is why it is very important for us to map these names and these IP addresses. So the DNS, or the domain name system, provides us this mapping possibility. So these mappings are all done in sort of databases, because all these spaces we can call it as databases, or simply in DNS terminology we can call those as zones. So inside those zones we have these mappings between names and IP addresses. So I think at this stage I just want to quickly stop here. Just to sort of answer your question. So we started with a very basic answer saying that DNS is an entry point to the internet, and then I just explained you why we say like that, because humans we can't remember those IP addresses, so instead we try to map those into a name that we can all remember.
Thanks, Shampika. So for the more non-technical audience, which is also like me, my understanding from this is that when we want to visit a website or an application, all the data on the website or application are hosted somewhere. So on a particular machine or server. But every machine on the internet has to have an address, which is an IP address. That's what you're referring to here. Then the system can find the IP address to bring the data back to you. But for humans, we cannot remember the IP addresses. So what helps us be able to find the data on that server is if we have a domain name that ties to the IP address. And this way, we can easily remember where my favorite website is, for example, like APAC DNS forum.my. So this way you can remember where it is. Is that a good summary?
Yes, it is.
Cool. So I'm just thinking that basically for humans, if we want to access the internet, we basically will have to rely on the DNS. And it feels to me that means that everything we're talking about, the internet related, kind of sits on the DNS in a way. And I'm just reading Statista.com. Southeast Asia's internet economy size is valued at like 105 billion in 2020. That was last year. It's projected to grow 3 times by 2025 in 5 years. I think the pandemic had fast forwarded a lot of the digital adoption and digitalization as well. So this number is just like estimation. And even just Googling yesterday, the global digital economy was valued at 11.5 trillion in 2016. I bet that's a lot more now. And it really feels to me all of this sits on the DNS. Am I right to say that?
Yeah, good question, actually. Okay, now, if you view this in a technical angle, of course, if you remember, I was explaining earlier about TCP/IP, and internet can still function. The data packets can still flow as long as, we deal with IP addresses, because, that's where the network layer, if you remember, the TCP/IP layers that we talked about. So as long as we have the IP addresses, we deal with the IP addresses, the packets can flow. And you can even...
Can you go to the slide before? Yes, we're still able to see your slide.
Yes. So
and this will help.
This is the slide I was talking about. Yeah. And so that's the layer that I'm talking about, the network layer. So this is where we give the directions, how the packets, say from A to B, if the packets has to be flowing from A to B, we need to give directions where, how these packets should flow, where should be the destination network, where should be the destination host, and so on. So that involves the routing function and the the destination of the particular packet. Now, so technically this can work without DNS, but the thing is, if you talked about all those financial figures and so on. Now this is all the businesses, the corporates. They have to do their business. They have to run their business, and so basically they have to have online presence. So if you want to have online presence, then it's not going to be possible for us to deal with only the IP addresses for all the reasons that we talked about earlier. And this is where we have to have DNS. And so if you don't operate your DNS properly, or if the DNS do not function properly, all those businesses, corporates, entities, and so on, they will not be able to operate their businesses, and they will not be able to have some online presence. So in a way, you can say that all that you can bring all that financial figures into the picture here and say that DNS plays a very big role in terms of that factor.
Okay. We'll come back to the impact and how important the DNS is in a little bit, but let's dive in a bit more. I think we don't have to shy away from some of the technical areas about how the DNS works. So we talked conceptually how the packets have to move and look for the servers and so on. But because maybe you can give us a more insight exactly how does the DNS work.
Yes, so let's have a look. We have a slide for that. So how DNS work? Now here, there are a number of components that you see in this graphic. Now let's look from the client perspective, the general user, right? So the user having their user devices, it could be a mobile phone, it could be a laptop, and you having all your applications over there. Say you want to visit a certain website, so you're doing some browsing. So browser is your application. Now, in our user device, the client device, we have an operating system, and then we actually run something called, in DNS terminology, we have something called a stub resolver. So stub resolver is actually, that's a piece of software that basically interact with the application. And so when your application, say the browser, if you type a certain URL, certain domain that you want to visit, then the application will need to know that IP address that we talked about earlier. So it will contact, so there will be a call from the application to the stub resolver that it needs this answer, the IP address, and the stub resolver would send this query. This is what we call a DNS query now. So this query would go to another type of server called recursive resolver. Now this is known, from DNS terminology. We have different names for this. Sometimes, you will hear something called a recursive server or even caching server and so on, but the functionality is same. So we have this recursive resolver. Now, typically, this is operated by the internet service providers, so ISPs, or it could be mobile operators. They are public. There are some public resolve operators as well. And sometimes even some of the corporates, they do operate these recursive resolvers. So either way, the client would send this request to this recursive resolver operated by any of those parties. And then these recursive resolvers, they have to go out to the internet and talk to these various servers called authoritative name servers. Now, these are again, DNS servers, but the functionality is a bit different to these recursive resolvers. Now, as the name sounds, authoritative name server means you are keeping certain data authoritatively, which means you are the one who owns it, or you are the ones who can give reliable answers for those data. And how you're going to keep this data? You're going to keep this data in databases. So which means all these authoritative servers, they have to have some database, simply a database, but in DNS terminology, we call it as a zone or a zone file. So there are different type of authoritative name servers. For example, you will see there are names called root servers, top-level domains or TLD servers, second-level domain servers, and so on. And all these, whether it is root or TLD or second levels and so on, they still have to manage, or they still have to have an authoritative server, authoritative name server that has data related to their, their zone. And so that's what this recursive resolver is actually, contacting all these authoritative server and asking for that particular data to find the referral. So the recursive resolver will go through this hierarchy, because this root, TLD, second levels, and so on would map to that hierarchy that I was showing you before, the hierarchical database that I was showing you before. So the root would give a referral to the TLDs, and TLD would give a referral to the second level domains. And then the answer, what is needed, is received from the second level domain in this case. And the recursive resolver gets that answer. It keeps that answer in the cache or in the memory, for example. And then the answer is given to the client. So when I say the answer is actually the IP address. So once the client gets that IP address, client has got the answer what it needs, and then the client can then separately go and visit that, or go and connect to that website or the web server, basically. So that's how a DNS query get resolved. So that's in a simple way we can say how DNS works. But obviously this is a very high level diagram. There can be different layers of recursive resolvers. There can be things like caching forwarders in between, where the query would flow from one resolver to another resolver, and so on. And also there could be multiple authoritative name servers, because we still have to think about redundancy and so on. So there are several factors. But then in a sort of bigger picture, this is a more kind of simpler diagram to show how a DNS query gets resolved, so that the client can visit, in this case, a website. It's the same way if you want to send an email, or even if you want to have use any mobile app, and so on.
Thanks, Shampika. Incidentally, I think we got a good question, very relevant to this slide, from BK Fu. He asked, for the recursive resolver, is it a DNS server like 8.8.8.8? Maybe you can explain the difference.
Yes. Now, this recursive resolver, as I said, there are, the whole function I explained you, the job of the recursive resolver. It is a DNS server, right? Simply we call it as a DNS server. And
Shampika, we lost you. You got muted.
I hope you can hear me now.
Yeah, just dial back a sentence before.
Okay, so I was saying that now this recursive resolver is simply we can call it as a DNS server. Now, the job of this recursive resolver is to go and contact the authoritative name servers, find the answers, and give it to the client. So the people or the entities who operate these recursive resolvers can be different. There can be multiple parties who operate these recursive resolvers. Sometimes our corporates, they do operate recursive resolvers in our organization, in our company, especially the big organizations. They have a team, they operate their recursive resolvers so that all the users within the organization, they use the organizational recursive resolver. But most common case, like when we are at home, when we have our internet connection at home, generally, our recursive resolver is configured as our ISP's recursive resolver. Or if you're using our phone, it is actually our mobile operator. They operate the recursive resolver. But if you do not want to use any of those recursive resolvers, you can still use some other recursive resolvers that are operated publicly. So these recursive resolvers are operated for public benefit, basically. And so the server that you just mentioned, 8.8.8.8, is a public DNS server or recursive resolver. And there are other servers as well similar to that. Usually, things like 1.1.1.1 or 9.9.9.9. So there are many of those. And then there are several other public DNS resolvers where many other parties do operate. And these are all called public DNS resolvers.
I think we'll go to public DNS resolvers when we get to Mike as well. So we can come to that a bit more in detail. We got another good question also, since we're on this slide, from Lakshmi, who asked, can you explain with more details of explain the details of a name server with example? So my understanding of your question would be, can we just use like an illustrative example to take us through the whole process, like say example.com or apacdnsforum.com? Just talk us through how it works in this process as well.
Okay. Yeah, so I hope now my early explanation about recursive resolver is clear. Recursive resolver is not going to keep any database as such, but these authoritative servers, if you consider here the authoritative servers, I told you that they keep a certain database. And if you consider, let's consider a domain called example.com. So you're going to go and get this domain name for yourself called example.com. So when you get example.com, you become a second level, right? You become a second level domain because example.com is the second level, whereas .com is the top level. And then above that, we have the root. So you are a second level domain when you have example.com. So now, next thing is you have to manage a database for that, because you are going to have several mappings. If you remember in the very first slide, we talked about mappings. And so you need to map your web server name to an IP address. You need to map your mail servers. You need to map your other hosts in your network. So you're going to have a lot of these mappings. So you're going to actually have all those mappings in this database, and you have to keep that database. This is what we call a zone or a zone file. You're going to keep all that here in this second level domain server. But the thing is that you have to, this server is not enough, because in case if this server is attacked, then your whole database will be not accessible. So you will have to have multiples of these authoritative name servers. Either you can operate it by yourself, or you can ask another party to be your, what we call a secondary. So that's where the primary secondary concept would come in. Now, when so when you have your name server, then the question was about name server. So your domain would be example.com. You can name your name server as maybe, for example, ns1.example.com, because this is actually, if you're going to use a name for your name server within your own domain, So you can say, if you want to use your primary name server, you can call it as ns1.example.com. If you want to have a secondary name server, you can call it as ns2.example.com. Now, it is not a must that you all your name servers need to be in example.com. If you want, if you can ask another organization to run your name servers. It could be ns1.somethingelse.com or ns1.somethingelse.net, for example. So some other organizations or some other parties still can run these name servers for your domain. So that is what normally we do. You might get your own domain, and once you get your own domain, you are supposed to actually keep your database in a certain name server. And you can even find a DNS service provider who can provide that service for you, who can run these servers for you. Some organizations, they do that. They outsource this whole function to another party. Or some organizations, they run their own infrastructure, own name servers, and then they look after all that. Now, if you think of the simple name itself, you can just call it, as I said, ns1. Whatever the domain. I hope this provides some clarity.
Yeah, I think that's very useful, Champika, when you're talking from a company's perspective or an organization's perspective of hosting a domain name. I think from a user perspective, my takeaway from this slide as well is getting to a website seems so easy for us today. We take it for granted, but actually there are quite a lot of steps in between. And need to have like different organizations. You have to have an ISP, for example, who provide the recursive resolver. Then the root server operators provide the root server name servers. Then you have to have the top level domain server providers. Then you have the second level domain server providers. Typically, if you run your own website or you're a hosting company, like you mentioned. So there's so many different organizations that come into play to build this network for something which just takes me less than a second to go to a website. I think we'll come to this a bit more later, but we need to move on a bit more because of time. And for those audience with us, if you're interested in more material, there's actually quite a bit of material online that you can find. But I was just looking around, and I found a pretty interesting one that shows what a DNS is and how it works in comic format. So it's in 3 different languages: English, Japanese, and Chinese, and it's led by our colleagues in Japan from JPRS. I'll share the link here. If we have time, I'll show how the comic format looks like. I think it's a fun way to demonstrate how the DNS works. So let's move on very quickly to the next question. So like Champika, the DNS is not that well known to the man on the street. But when we think, and most people, when they think about the internet, they think about broadband, Wi-Fi, 3G, 4G, 5G, but not the DNS. So why do you think this is the case?
Yeah, I think I will go back to my previous slide of TCP/IP here, so that would actually provide the context here. Now, those terms, those technologies, what you mentioned, things like Wi-Fi or 3G, 4G, 5G, and all these are what we call access technologies. And the access technologies all we put in this layer. They all come in within this layer, right? Whereas when you consider DNS, DNS is an application layer protocol, because the application needs DNS to do that, the mapping or the translation to an IP address. So the DNS sits here. And that is why actually, when we cannot, there are 2 different contexts. So we do not mix DNS together with, say, Wi-Fi or 3G, 4G, and so on, because all those technologies are access technologies where it's all happening here, and DNS can work with all that. So I hope this provides some clarity.
Yeah. So I think sometimes just looking at the slide about how the DNS flows, the resolution process, probably scares some people. But I think if we talk about the impact, then people will realize why it's so important. So let's talk about like what happens if something goes wrong in the DNS. Maybe you can share some examples.
Okay. So considering this, this slide, now you mentioned, okay, what happens if something goes wrong? Now, first of all, we have to think, okay, where can the things go wrong, or what can happen? So this is where we have to actually think quite broadly, because just like what you mentioned earlier, in this whole DNS ecosystem, that is also why we call it as an ecosystem, because there are so many parties involved. Just like what you said, there are users, then there are recursive server operators, hosting providers, content providers, root server operators, and TLDs, registrars. There are many parties involved. So something can go wrong with any of these parties, and then just because maybe one party do not operate their component properly, the whole DNS, basically the users can get affected. Say, for example, this could be if this is a public DNS resolver. If this recursive resolver is a public DNS resolver, where a large amount of clients are using this, and in case if this cache or this memory gets polluted in this recursive resolver, then all these users going to get wrong answers, because for an attacker, it is possible to pollute this cache. This is what we call cache poisoning. So if this cache gets polluted, then this recursive server will end up in giving wrong answers to these clients. So the clients would go and visit some wrong websites and so on. So the things can go wrong. In the same way, if an attacker managed to corrupt the database inside these authoritative servers, so if the database gets corrupted, then this recursive resolver will get wrong data from this authoritative server. And again, the client can get wrong answers. If this recursive server is being hijacked, for example, so you as a client, you think that all your queries are going to this recursive resolver, but what happens if these queries are being hijacked and sent to another recursive resolver which is run by a attacker? So your queries are not going really to the proper one, your queries are going to a wrong one. So just like that, I'm just trying to give you a few examples where the things can go wrong. So there are many ways in this whole ecosystem where the things can go wrong. So that is why it is very important for us to actually secure this DNS infrastructure, and it is a collective responsibility of all those parties in the whole DNS ecosystem to make sure that they run their DNS infrastructure securely and in a stable way. Now, these losses in the recent past, you may have seen a lot of headlines and so on, where there are different types of DNS attacks that has happened, and created lots of losses, would go into millions of dollars and so on. So even, as I said, even a single attack can create big losses to an organization, to a bigger community. So it is very important for us to actually consider where we can secure in our DNS infrastructure, and to apply those best practices and make sure the DNS ecosystem is secure enough.
Thanks, Shampika. I think this is a good segue to move on to our next guest speaker, Mastura. So one of the key takeaways earlier is, we have so many different organizations and groups in the entire ecosystem. And if one person or one organization doesn't play their role very well, it would affect the entire ecosystem and affect the user's experience to be able to reach your own website, or even worse, if you can't connect is one thing, but then you get connected to a wrong page that pretends to be the right page and you get scammed. That's even worse. Let's move a bit to talking about the community that looks after the DNS. So, Mastura, can you share a bit with us, who they are? Champika alluded to a few names just now. Can you help us with that, please?
All right. Thanks, Gerald. Good morning. Thanks for the question. Good morning, everyone. Thank you for joining us for today's DNS Forum webinar. Okay, as deeply shared by Champika just now, there are we know that the DNS is the fundamental fundamental element of the internet. Yes, there are large of community play a vital role, okay, in order to ensure the DNS is running smoothly. Okay, so I will take this opportunity to share with everyone who is the key player play a vital role behind of this DNS. Okay, so let me share my screen so that we can have a look who is the player. Okay, can you say?
Yes.
Can you see my screen?
Yes, we can see your screen now. Please.
All right. Okay, the first one I would like to introduce the first DNS community or the industry key players who look after for the DNS. Okay, so the one of it, the IETF, the Internet Engineering Task Force, where this community defined on the global protocol standards. Okay, so when we're talking about the standards, basically these standards expressed in the form of request for comments, or we have familiar about the RFC terms. Okay, so this is the standard where the document of method, behavior, research, or innovation that related to internet. Okay, next we have another DNS community, DNS player, so which is Regional Internet Registry. Okay, basically, or we call it RIR. Okay, so basically in the world, we have 5 regional body that are managing for the distributing the internet. Okay, so basically we have like APAC for managing the Asia Pacific internet region. Okay, so we have Afrinic, we have Irene, we have LACNIC, and we have RIPE and NCC as well. All these communities work according to the respective regions, okay, in order to controlling, assigning, and distributing the IP address for the community, right? So if I can move further, okay, the next key player here is ICANN, okay, where the ICANN play a vital role, okay, in managing and maintaining of the domain name space and as well as the IP addresses. Okay, so next what we have is the IANA, okay, IANA, where the IANA basically the department of ICANN, okay, so helps us to manage or administrative the domain name space which involve liaison with the TLD, top level domain name. Okay, for instance, the top level domain name, so as MY, mining as the registry for the MY, basically any update, any communication on the .my information, we liaise directly with IANA. Okay, so a part of
Asura, we
that.
pause here. I think you gave some very good examples, like how you liaise with IANA. I think the IETF one, that's a good example about standards. Champika mentioned about IP version 4 and IP version 6. It's at the IETF that you develop the different standards. So that's where we're all using. Then I think just now Champika, when he talked about the DNS resolution process, you need an IP address for all the name servers. Then if you need IP address, where do you go to for our region? That would be with APNIC. So some very good examples. Yeah. So keep going, please. I interrupted you, but I think it's good to talk a bit about some examples for our audience.
Yeah, sure. Thanks, Jerong. Okay, so next, the key players, and also this one already mentioned by Chapika just now. Who is maintaining, right, the DNS resolver or recursive server. So this is to make sure for us able access to the internet, maintaining the network, okay, make sure our internet can be accessed as good as possible. So this is the role of the network operator or ISPs, okay. So meaning that if they maintain securely, stably, so meaning that we can access to the internet smoothly. So meaning that this is the main role of the network operators and also the ISPs, okay, to ensure and maintaining the internet access to the community, right? So if I can move on to the next key players, okay, registries, okay. So when we talk the registries, okay, who is actually the registries in the world, okay? So basically registries, we are referring to the home to the top level domain name. So meaning that who is maintaining the top level domain name. If I could give the example, the top level domain name, and also that one as well by Champika, we have like .com, right? So .au. So meaning that this zone or the top level domain name, we have the respective registries that maintaining that that particular top level domain name. If I could share the example here, okay, the VeriSign, for instance, is the registry for .com, okay, and MyNet, okay, we are the registry for the country code top level domain name .my, and we go to our neighbor, okay, Singapore or SG-Link, okay, so who is maintaining for the .sg, and also we have our neighbor as well, pengelola nama domain Indonesia or .id, which is these are the role of the registries, okay, to manage and administrative for the data for the TLD's domain name as well as the subdomain name under their purview. Right, so that is the main role of the registries. Okay, so meaning that in this context, registries always closely work with the IANA, okay, in order to make sure the top level domain name or the country code top level domain name is working as expected. Okay. Next, we have the registrars. Okay, who is the registrar actually in this context? Okay, basically the registrar fronting with the business website owners. Okay, so meaning that to help these business people or the entity, okay, to get to process the domain name. Okay, basically, okay, a business or website owner will liaise directly with the registrar. Okay, registrar will process the domain name registration, and registrar will communicate closely with the registries in order to get the domain name is registered. Yeah,
that's very helpful overview, and I love this slide. Really covers a key portion of the ecosystem. Can you share a bit more, Mas, if you can help us? You know, how do some of these groups get together? Like, it really sounds quite complicated if I'm someone who's never been exposed to this space. You know, there's so many different organizations, and they have to define a global standard like the IETF. How do they even agree to come together, and then how do they actually work together in the first place?
Right. Thanks, Jerome, for the good question. Okay, if allow me to share the history of the DNS, how DNS can take a journey in this world. Okay, so allow me to share for the next screen. Okay. Basically, this is the DNS history and journey. If we could start in 1958, okay, in back of the history where the Cold War was on, the US was investing a lot of investment in defense and technology. So during this time, under the President Eisenhower, the ARPA started. So meaning that the advanced research project agency started and introduced during this era. Okay. So, and moving further, okay, in 1960s, okay, the ARPA was getting stronger. Okay, so meaning that getting stronger and bigger. So further down, okay, next to the following years, okay, in 1969, the first message sent via ARPA network. Okay, so meaning that so by having this first message sent by via the ARPA network, so meaning that this is considered that the foundation of the internet and the beginning of the history of the domain name registry, okay, through the where we can communicate via the network. Okay, so next history of the DNS evolution. Okay, so later the task to simplify the networking was given to Paul Mokametris. Okay, so where he and his team was given mission to create frontliner, okay, for use network where the people only can use the name for any activities instead of the IP address. So with this, finally, okay, in year 1983, DNS was created, okay, by Paul Mokametris. Okay, then next to the following years, okay, in 1984, the 6 TLDs, top level domain name, are available. So meaning that we have like .com, we have .net, .gov, MIL, .org, then .edu. All right, so next journey in year 1986, actually we have actually a huge events that related to the DNS. This is where the IETF was established. Okay, so and at this time in this year as well, the DNS become one of the original internet standard. Okay, whereby two RFCs started for this year. So meaning that if I could share, this is the two RFC was started during this time. So meaning that RFC 1034. So which is a domain name concept and facilities, okay, and the other RFC was 1035 domain names, implementation and specification. And also within the same year, the domain name registration becomes public. So meaning that in year 1986, so the public can have the domain name with the extension of the TLDs, which available public to use and apply. So next, in year 1988, where IANA was established, okay, in order to managing and administrative all these top level domain name activities. Okay, so and lastly, we have 1998. The ICANN was established. So this is where the ICANN play a main role, a vital role to manage the entire the domain name and also the IP assignment to the respective key players. So that's about the history and journey of DNS, which makes our life nowadays easier. So meaning that we don't need to remember the IP address. We just can use our own, maybe our own name, our own brand, okay, in order to access to the internet.
Thank you, Mas. This is very good history. Maybe let's move on to talking a bit closer to home, to the actual user. Can you share, for example, say if I'm like a business owner in Malaysia, what have I got to do with the DNS?
Yeah, thank you, Jerome, for your interest to register, for instance, your .my domain name, right? So I'm proud to take this opportunity to share who we are actually. Actually, we are the registry and registrar for the MY. So you can come with us, okay, to have your domain name to be published or online. Okay. So basically, these are the main categories that we are offering to the end users, and you may choose which domain name which domain name category that you are prefer. Okay, so basically we have the new domain name category which we recently launched, which is biz.my and co-op.my. This is basically to help our entrepreneurs and also SMEs to grow their business to the global market. So meaning that if you have opportunity to apply the .my domain name, you can choose any one of the category that are relevant to you. Okay, so moving on. Okay, basically this is where you can apply your domain name. Okay, so registrant basically referring actually to the business website entities owners. Okay, so you can go to our registrar, to our partners, okay, to register your preferred domain name, your interest domain name, right? So mining as the registry of the MY, so we are a bit unique from others. So meaning that we validate the applicant supporting document across all the relevant agencies. Okay, this is to ensure that to build the trustworthiness and also security to use my domain name. And also this is the way how we can minimize the risk of fraud as well to our users. Yes, there are the agencies basically we are currently liaised with and working with, okay, to help the validation of the applicant information. Okay, basically we have the Companies Commission of Malaysia. Okay, basically this company the maintaining for the businesses in Malaysia. Okay, and also the society, we have a registry of society Malaysia. And also for the individual, okay, for individual, we work closely with the National Registration Department. So here we can cross-check the validity of the registered information before we can approve the domain name. So meaning that once we have managed all these validation and the process accordingly, so the domain name will be approved and the domain will be published to the public. So meaning that once the domain name is published, you can start build your website and this scenario where the DNS will take place, okay, to resolve your domain name as mentioned by Chapika just now. So the authoritative name server, the recursive resolver will take place in the internet in order to get your domain name accessible by the public.
Thank you, Masura. So my takeaway is, if I'm a business owner or somebody who wants to start a website, I need to get a domain name. First person I can reach out to will be a registrar. But in the case of .my, I can reach out to MyNIC directly. There seems to be a pretty rigorous process in terms of validation, but I think it really helps with the security and the trustworthiness of knowing that a particular domain name, you have a real person behind it instead of like, some bot or something. So I think that really helps us understand why it's so important to have this validation process.
Exactly.
Now, I'm looking at time, so let's move to Q&A. We have a fair number of questions, I think, for both Champika and Mas. So we might not have time for all of it, but let's take a couple, starting from the top. We have one from, I'm sorry if I get your name wrong, either it's Jean or Jean. How do you, sorry, I got the first question is, has there ever been alternatives to the DNS infrastructure being proposed? Champika, maybe this question is for you.
Yeah, I mean, see, DNS has been there for quite long, since like the first drafts were produced in 1983. So it has been there for long, and it has been always, stable, and all this time we have been using DNS. So there haven't been really much of other, sort of, operational type of solutions have been existing. But there have been some sort of, discussions and some work happening as well. For example, like DOA or DOA, what we call digital object architecture. So that is sort of based on digital objects where you have certain metadata. Based on certain metadata, you can identify a certain object or an identifier. But then, this probably, might need more work, I guess.
Thank you. Let's take another question. We may not be able to answer all of them, so I'll just pick the ones that I think might be more interesting broadly, and then we'll try to answer the questions directly in the chat, in the Q&A pod. I see another one that's quite interesting from an anonymous attendee. May I know if we choose different recursive servers like 8.8.8.8 compared to our ISP or telco's recursive server? What is the effect on our resolving process when we do browsing? Mas, maybe you want to take this one.
Yeah, thank you. Basically, the operator that runs for the DNS resolvers, okay, actually we can use any preferred that public DNS resolvers offer the service. Okay, so meaning that if, for instance, you are not, let's say you have an option not to use the ISP's resolvers, okay, you can have an option to use which is that you identify that resolver might help you to help the speed of your resolution.
Champika, you have anything to add to this?
Yeah, I mean, there are different factors that you might also want to consider. Say, some are quite actually. They think about, say, the response time, the latency, and especially when you have, say, a public DNS resolver. I'm talking about, the global ones. They have sort of clusters that are scattered around the whole world. So wherever you go, wherever country that you are in, you can probably get a much faster, better sort of, response time if you have one of those recursive servers. But then if at the same time, say, if your corporate DNS resolver is in a certain location, certain data center, maybe in your country, if you go to a different location and always try to access your corporate one, then obviously you may not get a fast response and so on. So depending on your situation, some people might want to have different type of recursive resolvers.
Thank you. I think this talking about public recursive resolver, sorry, is a good segue to our next speaker. So let's move on to our next segment. And thank you, Champika and Mas, for now. But we'll come back for another Q&A round. We'll take as many questions as we can, and those that we couldn't answer here live, we'll type your answer in the Q&A pod. So trouble my guest speakers if you can look at the questions. So let's move on to our next segment. Again, big welcome to our guest speaker, Mike. He's Alibaba Cloud's DNS Senior Engineer. Welcome.
Hi, everyone. Hi, Jiarong. Thank you for inviting me. I'm glad to be here.
Thank you. Now, we know Alibaba relatively well, at least for this region. I think everybody would know Alibaba for its e-commerce business. My wife buys a lot from Taobao, and like also the lesser known Alibaba business, AliExpress, which services the international market.
Yes.
Online shoppers would know the various promotions. Is a very competitive space, the e-commerce space.
Yes.
Then Mike comes from Alibaba Cloud, which if you're with some businesses and you need some cloud services, you would know them as well. But they do have multiple businesses that work with the DNS. And Mike, can you share with us, some of these businesses?
Okay, no problem. Before let me show my slide. I have a slide about Alibaba business.
Please.
Sorry. Yeah. Can you see the picture?
Yes, we can see it now. Thank you.
Okay. Okay, currently Alibaba Group has many different business. It includes e-commerce, cloud computing, digital media, and entertainment. Like you can see in these pictures, some familiar brands like Taobao, Alibaba Cloud, AliExpress, as we familiar. The entire Alibaba ecosystem has about 1.18 billion global active users. There is 900 million consumers from Chinese market and more than 200 million overseas consumers. So some business like Lazada and AliExpress and other service. Some people may know in China we have double 11 festival day like Black Friday, if you know it. And in the past 2020, we generated, I think the number is 74.1 billion US dollars in GMV during the 11 days festival. And our infrastructure handle more than 583,000 orders per second during the peak of the activity. For DNS related business, as one of the largest domain name registrar and manager DNS service provided in Asia Pacific, the number of domain name registered from Alibaba Cloud has more than 20 million, more than 14 millions, the number. For DNS manage and resolution service, currently, lots of our entire system are running on Alibaba Cloud. The underlying interconnection of Alibaba Cloud based on our DNS service and network infrastructure to connect each other. So the managed DNS service is not only provided for sales, it's also widely used inside our companies. Jaron.
Thank you. Maybe to help our audience a little bit when we talk about the DNS related businesses. So, for the registrar business, more than 40 million domains is a lot. Then you also talked about the DNS service with public DNS and cloud DNS. So who are your customers exactly when it comes to these businesses?
Okay, let me split it two parts. The one part is DNS registration. Okay.
Please.
Registration, yes. As we are domain name registrar, we work with registries such as Verizon. They they manage the .com, .net, etc. domains, and Scenic is for China country code registry. We provide a domain name online trading platform for for companies and internet users, also known as registrants. As shown before the slides, using this platform, it will become much easier for internet users, especially to buy a domain name or transfer their domain names to others. The managed DNS service, I said before, is provide DNS resolution service for customer and let me show this picture. And you don't need to build your own DNS service, and even sometimes you don't need to know about DNS, how it works. But From these resolution solutions, it provide a stable and faster domain names resolution, and it also has many features such as intelligent resolution, geolocated resolution, and security protection for users who use the resolution solutions. Currently, the DNS service we provide served more than 1 trillion queries per day. As we all know, companies that may have different tech background or environment for their system, like they may run their system in private cloud or public cloud, or some companies they have hybrid cloud environments. So our domain name resolution, we can provide a one-stop domain name service for all the users to help them to build a complete and a reliable domain name system. The last thing I want to mention is our public DNS service. As other speakers has already said about the recursive DNS service or public resolver. It provides DNS recursive for global internet users. The IP address it's not very hard to remember, to forget, I think. It's 223.5.5.5. It's our public DNS service. We also value our users' experience and privacies. For public DNS service, we adopted the DOH and the DOT into our public DNS service in a very early age to provide the users with more security DNS resolution service.
Thank you. I'm just looking at this slide. The bottom right numbers are staggering. 1 billion users and 1 trillion queries a day for your DNS service. And this is managed by you and your team.
Yes, we from the Alibaba DNS team, we host all these services for the company, for the public DNS service.
Well, I'm very impressed by these numbers. I'm just reading the 2020 Chinese Domain Name Industry Report. Incidentally, in our region, I think globally, Alibaba's DNS resolution service is ranked the top 3 in the world. I think it's behind Cloudflare and another company. So it really provides quite a lot of service and investment in this business area. And I'm curious, like, why does Alibaba? Most people would think internet companies, they focus more on directly interfacing with customers like e-commerce or social media. That's what we tend to know. Why does Alibaba invest so much in DNS related businesses?
It's a good question, but maybe I can answer it in a different perspective. Firstly, today there's many traditional companies. They are on the path of digital transformation, as you said. If you want to provide online businesses, at least you need a domain name to help your customer to locate you on the internet. As a domain name registrar and DNS service provider, and even for us, we also cloud infrastructure providers. So with all these combined, we can provide our users a completely digital transformation solutions and make their business online much easier, I think. Secondly, at the scale, the company, the enterprise, they became larger and larger. The interconnection management, lots of I think the asset, the service, the servers, they need to connect with each other. We put a lot of resource and effort to make the infrastructure system stable and fast. When the platform is strong enough, is stable enough, we hope it will also benefit our customer to help them to solve this problem they faced right now. The last thing, in recent years, we have seen some large DDoS attack. against the DNS system, like the famous I think it's in 2016, the DYN attack event. Yes, it cost a lot of number of companies their service offline because the DNS resolution is failed and the DDoS attack. The security protection for the DNS service is, I think, it's became much important than before. We have deployed thousands of DNS service nodes around the world with some technologies like BGP, Anycast distribution deployment, and multi-access. We can provide, and at least we reduce the risk for our customers to face this security problem and make their domain name service much safer.
Thanks,
yes.
Mike. I think it's very insightful. Basically, it's all part of the overall digitization strategy, right? So
yes.
helping your customers go online and just coming online itself is not enough. So you need like a domain name to come online, but also the speed of being able to visit the website, get the data that you want, to store your data, and even to protect your data online. All of that ties in together as part of the broader digitization strategy. And it all ties in with the DNS. So again, it talks about how important the DNS is overall, not just from a user perspective, even from an enterprise perspective, but also from, say, from a service provider perspective, from, say, a large company like Alibaba.
I'm sorry, there's a...
Yeah, no,
yes.
Yeah, so I'm just saying that I feel that the what you're saying, my takeaway from what you are saying is that it's important to invest in DNS because DNS serves as a foundation for the overall digitization strategy. And I think that for me is a big takeaway when we talk about the impact and importance of the DNS overall from different angles.
Yes. For the people who maybe I think we can explain this way. The question is, some people they are using DNS every day, but sometimes they know it's not quite as a DNS service. They serve as a internet infrastructure service. Almost everyone using it on the internet, but a few people, only like us, for DNS engineers, we care about it. But some people, they don't care about it. They just think the DNS service like air. Yes, the air, we don't notice it all the time.
Yeah. So maybe we can follow up with this, like, so why do you think, any other points for why do you think people should care about the DNS?
Okay. I think this, like I said before, the DNS service is very important, and sometimes we ignore it because we think it's stable. It's so stable, and sometimes you don't feel it exists. But if you run a company, your DNS infrastructure is very, very important for you. Sometimes if you run your business, you use DNS to connect your customer with your service. It's must stable service for using the DNS. The DNS you must I think for some small and medium-sized enterprise, they may build their own domain name systems. After they test it, just throw it for the corners. I think when the domain name the domain name system is unavailable, maybe sometimes system performance issues or under DDoS attack, it's much difficult for them to deal with those problems. When they don't care about it or they don't know it very professionally. Their entire business will be affected, not only the revenues, but also cause a lot of large number of customers loss. For this situation, it's maybe for these companies also known as SMEs, it's better to choose a good DNS providers. And for the other hand, as we saw there's in the past few years, sorry, as an internet user, some people concern their privacies. But as we all know, DNS is a very old protocol. Most domain DNS data interactive today on the internet is transmitted in plain text. So it's not very hard to collect your DNS query data. So if you care about your premises, I think you can try to use some technologies like DOH or DOTs to protect your premises. Yes.
Thank you. I think that's a good takeaway as well. When we talk about privacy and security, these are important topics for us today as users. And in terms of the DNS, these are also areas that we have to watch out for and to see how our privacy and security can be better protected. I'm very sure we will have another webinar, and during the actual forum, we will dive deeper into these areas. So we have 10 minutes left for this webinar. So let's pause here and then let's do Q&A for everybody. Again, for Q&A, you can raise your hand and speak. Otherwise, you can type your question in the Q&A pod. And if you're watching with us, joining us on YouTube Live, type your question in the comments and we will pick it up and address the questions here as well. So let's look at some questions again. We have one question from the YouTube live streaming. What is the difference between Google DNS and Auto DNS? Maybe I can ask Champika to answer this question, please.
It's Auto DNS. Is that what you said?
Yeah, it's typed as Auto DNS, but I'm guessing maybe what the person means, the question means is public DNS, probably.
Yeah, I mean, I'm not sure exactly what he means by Auto DNS, but I would imagine it is sort of default service. So if their default service is actually directed towards say their service provider ISP, that would be their default DNS server that the queries are going into, and then obviously Google DNS is the public DNS service. I mean, not only Google, but there are many other organizations who do provide public DNS services, and Google is only one of them. And there are many of those as well.
And another question from Imran Hussein. Can we tell without the DNS whether the internet will not work? Is the DNS the mother of the internet? I think it ties in a little bit to the question I asked about, everything sitting on a DNS. Any thoughts? Who would like to take this?
I mean, I pretty much have to tell the same thing, actually.
Yes, maybe I can notice these questions. So DNS, if you don't use DNS, I think it's in a local environment, you can make it work. You can just connect with the IP address, just like explained before. But in an environment like internet, there are lots of servers you need to connect with each other. So you can't remember all these things. Even for Google service or Alibaba service, behind the domain, there are lots of servers. They need to connect the users. They need to maintain the load balance with different servers. And so it's very hard to remember to use the IP to connect.
So perhaps I could add to that.
Please.
Yeah, thank you. So I would say the DNS is the mother of the internet as well, because DNS play a vital role. Because if you can see the resolver, the function different from the authoritative, right? Authoritative has different function from the recursive or DNS resolvers. So this one is connected each other. So meaning that if you don't have the internet DNS used in daily communication, so meaning that it's hard for you to reach everyone in the easier manner. That's
Thank you. Yeah, Iman has a follow-up question. Is there any security issue if we use public DNS like Google or Cloudflare? Like, would they collect our data, etc.? This is an interesting question tied to security and privacy.
Yeah, I mean, see that's you just have to actually then depend on that whoever the public resolver that they are operating. And so what you need to actually understand is that whoever the party that is running these resolvers, say if you are not encrypting these queries, which means if you're not actually, if you haven't deployed any encryption sort of protocol, then these queries, these DNS queries can be captured, and whoever the parties that are running the resolvers, they know exactly where these queries are going. So it is actually always possible for someone to, whoever that party, to do some analysis. Maybe that analysis could be done for betterment, maybe to actually improve the infrastructure, or it could be possible to do some monetization as well. So always that's possible, but then we don't know exactly.
Thank you. All right, we're tight for time now with 3 minutes left. Let's wrap up a little bit. Let's just quickly talk about, for our guest speakers, what is something you hope that the inaugural DNS forum come next March? What do you think what is something you hope that the inaugural DNS forum can discuss or achieve? Chapika, let's go with you first.
Yeah, actually, maybe I will just try to quickly share a slide here, because I can just talk about considering the whole DNS ecosystem. If you just like the questions that was asked, because there were a number of questions related to security. So our objective here is to make sure that the DNS ecosystem is secure. So today we talked about the understanding how DNS work and what is DNS and how the queries happen, and then the things related to the whole ecosystem, the organizations that are involved, and some experience sharing from industry perspective and so on, which is pretty good. This has given some good foundation. But in the future sessions, I think it would also be good for us to focus on some security aspects as well. So here in this graphic, in this diagram, what you see is various entities, various components of this whole ecosystem. We talked about recursive server operators, we talked about clients, we talked about authoritative server operators, registries, registrars, even the registrants, how they're going to actually update their systems using different interfaces and so on. So there can be several security incidents can happen in all these places. So if we do not protect our DNS infrastructure, the things can go wrong. So in future sessions, we can perhaps cover some of these different aspects where how we can protect our DNS ecosystem, how we can secure our DNS ecosystem. One of the things I want to highlight is actually something here, what you find, DNSSEC. Now, DNSSEC, the arrow is pointing here, but then obviously, this is much broader than this, just the label here. Now, DNSSEC stands for DNS Security Extensions. Now, DNSSEC protects the DNS data. And we are going to use DNS data pretty much, in many places. For example, DNS data resides in these databases, DNS data resides in these recursive server caches, and so on. So it is quite important for different parties. There could be recursive resolve operators, there could be authoritative server operators, there could be the other corporates who are operating their own domains and so on. So for all these parties, it is important that they do deploy DNSSEC in a certain way which is applicable to them. For example, that ISPs have a certain function, certain responsibility in terms of DNSSEC deployment. The authoritative service providers, they have a certain functionality, they have a certain responsibility in terms of DNSSEC deployment. Even the users, if the users can pick the service provider, if I am a user and if I want my ISP, when I'm selecting my ISP, if I have a choice, okay, whether I should go for ISP who has deployed DNSSEC, that would give me some better option in terms of securing myself, or whether it will give me some assurance that I'm not going to go to wrong fake websites and so on. So these sort of areas can be covered in some future sessions, like DNSSEC, go a little bit in depth, broader to some of these DNSSEC related discussions, focused on certain industry segments. I think these would add some more value to future webinars as well.
Thank you. And Mas, just very quickly, what would you like to have the DNS forum cover?
Yeah, so I will suggest if we can have like training and more awareness to the attendees or participants, so that on how to secure the digital branding from the threat and domain hijacking, and the challenges facing by the domain name industry during this pandemic COVID-19. So meaning that we can have more insight during that session. So that's my hope.
Thank you. And Mike?
Yeah, I think just like the theme of the forum, Beyond Technologies, the revolution of DNS. I hope the 2022 forums will bring us some new perspective about to know about the DNS, introduce some technologies, innovations, and evolutions, and how this technology change can influence internet users. That's what we want to see. And for the achieve the target, I think I really hope the forum can establish a more efficiency cooperative mechanism for our Asia Pacific communities, because in the last I think in the past years we have some problem about in another part of the Asias. We want to find how the ISPs they manage their DNS service, how they influence with us, but it can't. We can't know how to connect with them. So I think it's better to build this channel to share information, to connect with each other. I think it's a bit better.
Indeed, it's very helpful. I think that ties in with and look at how we can collaborate and help each other. And during this, players, different organizations that are involved in different parts of the entire DNS chain. So it's important for us to find a way to work with each other. Now we have run out of time. So thank you everyone for staying with us. And it's a very interesting scene setter webinar. So before we go, we'd like to invite everyone, after the webinar closes, we have a survey that will pop up. Help us to get better. Please give us your feedback. And during the survey, you will also be able to let us know what topics you'd like us to cover during the APAC DNS forum. And if you're watching on YouTube, you can also take our survey by visiting apacdnsforum.my. We talked about today, if I gave you the IP address, you wouldn't remember, but apacdnsforum.my, much easier to remember. So be sure to register, and then you can receive any news for our next webinar, which is planned for 14th October. And the next webinar will dive deeper into the DNS industry and cover challenges and opportunities, particularly for our region. So hope to see you then. Thank you very much. We'll close the webinar now. Thank you. And thanks again for our speakers.
Thank you, everyone.
Thank
Thank you,
you.
everyone.